My name is Chetan, and I'm here to talk about a study that I did for my bachelor's thesis. My study was on the evaluation of India's wind energy potential. Now, this is a very important topic because wind energy in India is a very, very big industry. It employs thousands of people and it's a billion-dollar industry. And it's always performed better than people expected it to perform. The reason being that a lot of the wind energy produced in this country is bought by the government. So it's a subsidy-driven market. And that's why a number of companies actually see a reason in investing here. But the big thing is that the government has only so much money and they can invest only so much. And they make that decision based on the amount of potential that this country holds. So assessing the potential that can actually be converted to energy is very, very important. Now this number is decided by an official figure, by an official study, which was done by CWET in India, which pegged the figure at approximately 100 gigawatts. Now there were similar studies done in China and the US, and they are all based on assumptions of technology as well as land use fraction. Now the assumptions of technology change with time, and there were newer reassessments done in China and the US, and China especially, with higher hub heights and stronger turbines. It turns out that the new figures are 800% more than the old ones. So this triggered a reassessment for India as well. One of the biggest reassessments was done by the Lawrence Berkeley National Laboratory, a very, very respected lab, which pegged the figure at approximately 2006 gigawatts at 80-meter hub height. Now, when we took a look at that study, we realized that there were some caveats to that. And we tried to come up with a method that would explain those caveats or at least point them out. In our study, what we've done is we've taken wind feed data, we've figured out a suitability fraction for the land, and what we've done is instead of taking one hub height or one single rated turbine, we take multiple turbines, multiple ratings and multiple hub heights. And we also filter out the land based on different capacity factors, because capacity factor is what essentially makes investment sense for a developer. Now, we did this study and we came up with maps of India with varying capacity factors. And the one thing that our study really does is whatever figures of capacity factor we came up with, we checked those against actual wind farms existing in India. And it turns out that our figures actually match up very well and we can explain any differences. So our figures range from 170 gigawatts approximately at 80-meter hub heights using a 1.25 megawatt turbine, supposing that a 1.25 megawatt turbine would be used all over the country, to 100-meter hub heights using a 1.5 megawatt turbine, and these come up with a figure of approximately 700 gigawatts for the country. Now this is all depending on one land use assumption. Now this point that wind energy potential is essentially subjective and you can't limit it to one number is the main point that we're trying to make. We think that given more studies, more research about the likelihood of what technology could be employed now or in the future and what land use fraction would be feasible, you could figure out much closer potential for India's wind energy potential, because it essentially depends on what is feasible for businessmen, what is appropriate for policymakers to make decisions, and also between researchers. So it's a dialogue, and this needs greater research.